Hello, hello. This is Postgres FM. I don't remember the number of episodes. Michael, do you remember?
No, we must be getting close to 170 though.
Yeah, some really big number. Not as big as your max connections, right?
I like it. Good segue.
Yeah, my name is Nik, Postgres AI, and as usual, here is Michael, PG Master. Hi, Michael.
Hello, Nick.
So we are going to discuss really high max connections in general, and maybe we will touch a little bit connection pooling systems a little bit, and maybe we will touch per user connections, max connection setting because it's possible. Yeah. So in general, is it bad idea to raise max connections, and is it a good mitigation action when you have problems, right? This kind of actions. What's the ideal max connections?
And why do you, I think you've seen some cases recently where people are raising it and you think it's not a good idea. So is it worth kind of jumping straight into some recent experiences? Like, why is this on your mind at the moment?
Yeah, so I proposed this topic after a tweet I saw where it was shared that there was a pattern when deployments, I guess, schema migrations or DDL, were failing, but only in particular hours of every working day, or maybe every day overall. And then they realized that at the same time, during a couple of hours, some data pipelines were running. And they just raised max connections and that's it. Actually, I'm not sure max connections because it doesn't say which database system it is. I just assumed it's Postgres because Postgres is default choice right now. I might be wrong. Maybe it's different databases.
I took a note and it said the solution was 1, separate connection pool for migrations, and 2, better cross-team communication, which I thought was interesting. But yeah, maybe separate connection pool for migrations is where you're drawing that conclusion from.
Well, this doesn't sound as a mitigation for me. It sounds like isolation of problem.
Yeah.
Maybe. Well, I might be wrong. So again, there are several possible options here, but I bet what happened, these pipelines produced long-running transactions, right? And these long-running transactions blocked some DDLs, alter table, add column, for example. And this DDL blocked any queries to this table. And number of active sessions spiked and reached max connections. If you start isolating, maybe if you start isolating, everyone will suffer anyway, right? So this idea that somehow isolation helped somehow, if this theory is right, then separate connection pooler for migration and pipelines doesn't help at all. Because locks are global, right? So you don't lock a table only in the context of some connection pool. You lock it globally in this database, right? In this logical database.
Yeah, so if it really did mitigate the issue, either it was the other part of their solution, which is the better cross-team communication, or the theory's wrong and actually it was a case of these migrations taking up a few slots, a few connections that weren't that the application expected to be able to use.
Migration needs only one connection, right?
Yeah, true.
So, how could it data pipelines take a few connections?
Yeah.
I don't understand how they can exhaust and reach max connections at all.
Well, should we talk about the general case a bit more then?
Yeah, so again, this general case is described and we discussed it a few times. Everyone should understand that any alter statement, if it requires a lock, exclusive lock on a table. Even, there are exclusions, for example. Well, no exclusions actually. Alter table is a serious thing. Even if it's super fast, you still need a lock. Mm-hmm. And if you, with default settings, fail, if your session fails to acquire this lock, it will start waiting. It will wait forever with default settings. Default settings means a lock timeout 0, statement timeout 0, transaction timeout 0, idle transaction session timeout 0. Everything 0 means forever, infinite, right? waiting infinitely. So this means it will be waiting, but any query, including any select to this table, will need to wait behind us in the line. So there's a queue forming there, waiting queue, lock queue, blocking queue, and actually you might see multiple queues, and it forms trees, and actually not just trees, it forests. So it's beautiful. Like it can it can look really great, like forests of blocking or locking trees. But this is eventually like what accumulates a lot of active sessions, can overwhelm your server basically. And even if it's not achieving max connections, it can reach to high CPU consumption, of course, and so on. But very common to see that max connections is reached because too many active sessions, right? And most of them are just waiting. So you can, when you reach max connections, any additional attempt to connect will see an error, right? Too many connections.
Yeah.
Too many clients, or how's it? I don't remember. Too many clients, I think.
Yeah, I can't remember either. I remember back in the day when a lot of people used Heroku Postgres. This used to come up all the time because they were much stricter on how many connections they would let you have. And these days, with more people on things like RDS, who have much higher default max connections than Heroku ever has, I see it much less that people are hitting this. I think probably causing other issues. I'm sure we'll get to that. But it's interesting that used to come up more in like various online forums.
Yeah. So in the past, so we need to distinguish the states of sessions or connections. Connections and sessions or backends all are synonyms in this context of Postgres. So we need to distinguish active, idle, and idle transaction. Three main states, and you can see states in selecting it from PG set activity.
Mm-hmm.
So before Postgres, I think 12, 13, 14. So 5 years ago.
Is this the Andres Freund work?
Right.
Yeah.
A couple of articles published originally in Citus blog, then in Microsoft blog, Microsoft Azure Citus there, right? So a couple of good articles, like excellent articles, first researching and then like discussing optimization. So usual fear was that idle connections consume memory, but articles prove that the main problem is that how work with snapshots is organized, and idle connections, for example, if you just add 1,000 idle connections, it can hurt your performance. And I demonstrated it with benchmarks easily as well. So it was quite easy to see, but so if you have, I think 14 plus, maybe 13 plus, if you have this Postgres, basically everyone right now.
Oh, true. It's all supported PostgreSQL versions now. That's incredible.
Because 13, we have a couple of cases where 13 is still in production and then talks to upgrade it. But basically right now, if you are on supported version, so idle connections don't hurt performance anymore too much.
Or anywhere near as much. Yeah, exactly.
Yeah. So having 2,000 additional connections, it's not a big deal these days. And also processors improved. I really like Graviton 4. It's amazing, and it handles a lot of connections, even active very well. I have my neural network trained what to expect from like 500 connections, for example, on a machine with fewer than 100 vCPUs, right? I can imagine what should happen, but on new hardware, I see it it's much better. It handles more active sessions much better.
When you say your neural network, do you mean your brain?
Yeah.
Okay.
My LLM internally. Yeah. So I expected this, but wow, guys, you are fine actually. You are not down. I would expect you to be down by this point, right? So we just see it in our monitoring, what people experience, what their cluster experiences. And wow, this is, and when they check what hardware it is, it's actually Graviton 4 on Amazon, which is great. I'm impressed.
And Postgres and
newer Postgres, yeah.
Yeah, okay. but you're talking about
So-
lots and lots of active sessions rather than idle. Yeah.
Additionally, on larger machines, RDS and Aurora RDS, they just set really high max connections. I think this decision was made. I'm really curious how this decision was made. And it's like we see 2,500, 1,500 or 5,000.
Yeah.
It's very common. I can already, like, looking at settings, I can tell you, oh, this is not seeing the settings which start with RDS dot. Just looking at this like profile of settings, I already realize, oh, this is RDS, or this is like Cloud SQL. It's like there are patterns of some decisions.
Yeah.
Random page cost 4 and max connections 5,000. Oh, very likely it's RDS.
RDS. Yeah. That's funny.
So this gives us opportunity to observe how clusters behave with high max connections, and old arguments don't work anymore. So old arguments were like, guys, like this is bad. Like you just have 2,000 connections, 1,900 of which are idle. Why do you do this? Because you just basically pay big tax over for performance wise, because like all the latencies, it hurts all the latencies. But now it's not so, and the only argument left, actually, in my mind, is that it still, if number of active sessions exceeds the number of vCPUs significantly, then it hurts performance globally, and all queries are processed for much longer time. Like latencies increase, and none of them have chances to be finished in time in statement timeout, which, for example, 30 seconds. So instead, it would be better if we reach max connection sooner and just say some clients retry later, like too many clients. But these guys would have much higher chances to complete execution inside statement timeout, right? So we have limited resource, CPU and disk I/O, right?
Yeah.
And
to make sure I understand, are we talking about if you allow too many connections, even if most of them are going to be idle most of the time, you run the risk that a bunch of them will become active at the same time. Yeah, okay.
Exactly. So if some wave of requests, unexpected or expected, but poorly planned, happens, if we have low max connections, we will have limited number of backends which will do job inside statement timeout. If it's limited. If statement timeout is limited, it's a different story. It's also a very wrong state for OLTP. We also discussed it many times. But if we have 10, 20, 50x compared to number of vCPUs, we actually have max connections, and this wave comes. All of them try to execute, but none of them will succeed because they will all bump into statement timeout. Or if statement timeout is not, if it's not set, they will bump into some different timeout on HTTP level, application level, or something like 1 minute or something. They will still not, like nobody like we took all the chances from everyone. That's the problem. If we limit, some of them will succeed. Some of them will need to retry because too many clients, and we will need to fix the problem. And of course, if there is connection pooler, it's great because connection pooler will take a lot of headache from Postgres backends.
Yeah, well, I wanted to ask you about this actually, because I think sometimes when one of us says connection pool, I think people can assume either direction, right? They can assume database side or application side. And a lot of the time I see people scaling their app and having application side pooling, and that's how I see. I think actually that's how a lot of the Heroku issues happened. A lot of the people running out of connection on Heroku, because it's so easy to spin up new versions of your app and scale the app horizontally.
Exactly.
But each one comes with another 10 connections, another 10 connections.
Yeah.
But they're using poolers, but it's application side, so there's no, and they don't use anything on the database
poolers
side.
are too far from database, and exactly this pattern I saw so many times.
Yeah.
Especially if you mention e-commerce, and they have microservices, many clusters, some cluster, we see it. Okay, Max connections is high because they don't use PG Bouncer. They say, okay, we have Java application and all the connection pooling is on our side. Hikari CP, for example, right? This is such a connection pooler. And all great. I cannot convince them to start using PG Bouncer. Not bad. Okay, max connections we keep somehow high because we have a lot of idle connections. Why? Because there are many application nodes. And then before Black Friday, which happened last week, this story was many years ago. Before Black Friday, infrastructure guys who are responsible for application nodes decided to double capacity. This is in their hands, right? Their decision. Okay, we need to be better prepared. Let's just double number of application nodes from 100 to 200, for example, or something. And nobody thought about reconfiguration of those poolers, so they were like 40, right? 40 connections. So it was, for example, I don't know, like 20 nodes times 40. It's 800, for example, right? Maximum number of connections, 800. But they doubled it, it became 1,600. I think numbers were higher in that case. And nobody talked to database team. It's just application nodes. Let's have, they're stateless, right? Let's add them. And this is how you suddenly see, many more idle connections. The actual load didn't increase. We don't need, number of active sessions didn't increase, but since capacity was doubled, the number of idle connections doubled, obviously. And you cannot solve this problem having connection pooler on application side at all. Well, you can, but you need to somehow memorize every time you add or remove application node. You need to rethink pool configuration for all of them to maintain the same overall number. Some of connections should be maintained, right?
So you mean if we double the number of pools, we can halve how many connections each pool has?
Yes.
Yeah, but then people, it seems brittle to me to then need to remember that.
Yeah, there are two numbers. There is minimum and maximum number. I'm talking mostly about minimum number.
Yep.
These connections are open and they're maintained and it doesn't go down below that, right? So if we doubled capacity but the actual workload didn't increase because it's not Black Friday yet, right? Why do we open more connections to Postgres? It's not right. And good solution here is to have additional pooler closer to database, where it will be configured according to database situation, not situation with application nodes and the needs to increase the fleet. Yeah, so connection pooler helps, and usually we say okay, if you have PG Bouncer, each PG Bouncer can handle 10,000 connections incoming, something like this, thousands of them. And it should open only 100 connections to database. This depends on the number of vCPUs. We still say take number of vCPUs times some constant. Usually it was 2, 3, 4. Now, we said 10. Because we see Postgres behavior improved, hardware improved, 10. But not more. If you have only 96 connections, 1,000. If you have 32 vCPUs, number of max connections should be 320. It should not be 5,000. I'm very curious how RDS team made this decision, because I guess I have several theories here. One theory is they saw many clients without pooling, and this was just a need, and let's do it.
It's just moving the problem, isn't it? It's instead of people thinking, what, I don't have enough connections, they're going to hit performance issues.
Maybe they have some additional reasoning which I don't get. I'm very curious. And another thing, maybe RDS proxy was not so good. It's still not so good. We saw it in action. RDS proxy, it's very weird proxy compared to PG Bouncer behavior. It's you see idle connections more. I don't remember all the details, but every time we touch it, we say why is it behaving so? Right? So what is this? Very strange. It's very different. There's no very good multiplexing capabilities like in PG Bouncer. You have 10,000 connections incoming maximum, and you transform them to maximum 100 backends. PG Bouncer is very reliable and stable to solve this task. RDS proxy not so much. So maybe they had issues with RDS proxy and they needed to raise max connections because it was not solving this task somehow. Yeah.
Interesting theory. If anybody knows more, let us know.
Yeah, I'm very curious. Yeah. So this is my approach right now to max connections as maximum 10x for vCPUs, ideally lower, so database can breathe under heavy load.
And lowers the risk, I think, is that, yeah.
Yeah. So
That's
yeah,
interesting.
just to be honest with you, how many resources do you have, right?
Yeah.
Do you have 1,000 cores? Maybe yes. In this case, no problem. Go for it. Because it sits sits all the time, like no problem. But then we have problem, and we have huge spike and unresponsive database, right? Database system.
Yeah,
So,
exactly. It's picking what do you want your failure case to be, right?
Yeah.
Do you want your failure case to be some people can't access it, or do you want your failure case to be nobody can do anything?
Yeah, and also if some attempt to connect and execute a query from backend failed, backend should have a retry logic.
So should we...
connections and in query execution, in both. So it should be handled there properly. Additionally, if users immediately see there's too many clients, well, okay, maybe you should additionally adjust your application code. So to have ideal state is a retry logic with exponential backoff and jitter. Right? So this is like more scientific approach. There is a good article, Amazon article about this. It's not rocket science, but it's good. There is some science behind it. Exponential backoff and jitter. So it can happen quite fast, and this adds some resiliency to like this system a little bit. Of course, if you have 500 max connections and all the time all of them are busy, yeah, that will be the users will notice this, right?
Yeah.
But still, those who are still working, they will have more chances to complete, and this is, I think, super important. Then sit with like welcoming performance cliff, basically. Yeah. But another thing which I'm curious in is how to demonstrate a problem. Naive attempts failed so far, so I don't have a good article of demonstration how this performance cliff behaves. I name it performance cliff, maybe it's wrong as well. But I feel it's somehow like, not maybe cliff, but somehow too high max connections increases risks to be down for everyone, and how to demonstrate it, this is I'm not sure. So these considerations are more theoretical. So we have many clients who listen to us, agreed, but max connections, to change it you need a restart. So they still sit with 5,000. That's it. At the same time, I'm not super worried. Well, I still believe we need to go down with max connections and plan restart and do it. So unfortunately, some companies are afraid of restarts and like try to minimize it. It's another question, right? How to stop fearing restarts and do minor upgrades more often and so on. But another fact, okay, if you have two max connections, it's also good because, in our monitoring we put active session history analysis, wait event analysis in the center right now, and it's quite great to see very colorful, beautiful graphs. If we have a lot of max connections, a lot of areas with different colors, it's so good. It was a joke, right? So
okay.
I mean, if you have max connections high, your graph's looking better,
Oh, I see what you mean. Yeah.
Postgres probably is not responsive, right? Yeah. But graphs look really great.
Okay. Well, I'm interested in the pool. Like, I do think we do need to justify. Like, why should you have an extra thing running? Like, it's more complexity to justify, right? It's another layer if we're saying you should use PG Bouncer, and added latency. Like, maybe not much, but there's a bit of extra, right? There's one extra hop. So I do think it is sensible to have to demonstrate what is the advantage. Yeah. Well,
it's quite easy to demonstrate the benefit of having PG Bouncer. in between. There are certain types of workload where it will be very noticeable that PG Bouncer improves. And also if you have slow clients, it improves things because backend's not working on transferring data and like it's offloaded to PG Bouncer.
Yeah. Okay, that's a good one.
Yeah. But also, if you take a lot of fast selects and with PG Bouncer, it will be much better than they were without PG Bouncer. Because, for example, you achieve 1 million TPS with select only PG Bench, right? And PG Bouncer helps Postgres to communicate and start working on next execution. So you can feel it, and you can raise number of clients easier and scale better. This is a simple benchmark actually. Usually in this like stress load testing, we start with 1 client, like 2 clients, 4 clients, and so on, a number of parameters -c and -j, lowercase, in PG Bench. We match them because there is interesting logic. Not everyone understands from beginning how these parameters are connected to each other. And then we just grow, but usually when we grow to the number of vCPUs, we go beyond that and TPS numbers go down, latency goes up, right? Because, and this is ideal state for direct connection benchmark. We just scale until the peak, which matches number of vCPUs, right? If peak starts earlier, there is some interesting bottleneck, I bet, some lightweight lock or something. And then if you introduce PG Bouncer, this peak should shift to the right and become higher. Yeah, that's how you can see it.
Well, is that an easier way to sell it then, instead of like trying to convince people to use it because it reduces the risk around exhaustion of resources? Well, actually, just try and sell it on the increased performance.
There's no problem to sell PG Bouncer. Everyone wants it. Almost everyone.
Well, interesting.
Yeah. Well, I talked about that company. There I couldn't sell it. These days I see everyone understands quite easier that connection pooling is needed. And also keep in mind that I just said a lot of very fast selects. If you have long-running statements, quite long, for example, 10 milliseconds or 100 milliseconds, it's quite long. It means if 100 milliseconds, it means execution 100 milliseconds, including planning time. It means that one backend can do only 10
per second.
QPS, TPS, yeah. It's not a lot at all, and that's it. And communication overhead, which PG Bouncer will take on its shoulders, will not help a lot in this case. It will help only if you have tons of fast selects. In this case, this overhead will be comparable to execution time, right? Or maybe even higher somehow. Sub-millisecond selects, this is what we need. And guys can tell you, you know what, like we don't have like so many, like depending on application, but sometimes we see average query latency is exceeding 1 millisecond significantly. In this case, PG Bouncer will have, but not so much. Well, again, depending on the clients, sometimes clients are slow, sometimes they're under control, not so slow. So, but anyway, I just, from my experience lately, dealing with a lot of startups, including AI startups, which grow really fast, everyone understands connection pooling is needed. Usually it's a trade-off, like if it's RDS, what to do, because RDS proxy is managed, no-brainer, but they lack good behavior, as I said, and also they lack post-resume, which is weird because, there's blue-green deployments, but RDS proxy doesn't have post-resume. It means that there is no zero downtime possibility here to maintain connections, right? And PG Bouncer has it, but you need to deal with it yourself. And if you go to a global database in Aurora, it sticks you to RDS proxy more.
So what's their blue-green deployments doing behind the scenes if it's not?
I don't know about blue-green deployments. They do the logical replication and everything. This is what they do. But this switch, if it's through RDS proxy doesn't have post resume. I know it, right?
Yeah, interesting.
Well, maybe I haven't checked a couple of months. Maybe I have outdated, but I didn't see the news about post resume. I think the switch is still like interrupting current execution, so it's near zero downtime, not fully zero downtime.
So when you were going back a bit, I'm a bit confused. You were talking about folks or not being able to demonstrate kind of a theoretical limit of what's the added risk. Why would you need to demonstrate it? Like if you're seeing everybody using a database side pooler like PG Bouncer already, who's it for that demonstration?
So let's distinguish two things here. First is how to demonstrate the need in connection pooling. This is a slightly different topic than reconfiguration of max connections.
Yeah, but very related, no?
Related.
Yeah.
But I find it easier to convince that connection pooling is needed compared to let's reduce max connections.
Okay, so people are like, we'll have a pooler, but we'll also still have 10,000 max connections.
Yeah.
Interesting.
Well, it may be just because it's painful to restart for them. That's it, honestly.
Yeah.
You know? Yeah.
And if most things are going through the pooler and the pooler has a lower limit, then actually they might not get near their max connections. It's just a number, not actually how many connections they have.
Yeah, I'm checking blue-green deployments once again, and I don't see post resume, and I think switchover it allows connections in both environments, allows write operations on one cluster, on only read-only on another cluster. And then you need to take care of everything yourself. This is undercooked, I think, situation. They should have post resume in RDS proxy, or just ship PG Bouncer in a managed form, as some other managed platforms do, right?
Yeah,
that's
true.
it. In this case, it would be possible to achieve fully zero downtime. And we know, like our standard criticism of blue-green deployments that it's not blue-green deployments because you lose one environment after switchover, which is super strange. So it's not reversible.
It's not reversible.
Yeah.
I don't think you lose it, but it's not reversible. Yeah.
Yeah. So I don't find problems to convincing about the need of pooler, but it's easy to demonstrate that pooler brings benefits to certain types of workload significantly, but how to demonstrate, by the way, we could emulate slow clients. In this case, it will be even more interesting to see how with PG Bouncer, Postgres behaves much better, higher TPS, healthier state, lower active sessions, and so on. But when we move to the topic, max connections, forget about pooler. How can I see that lower max connections is somehow beneficial? Here I have hard time right now. If anyone has ideas, let's work together and create some benchmarks, demonstration, tests, experiments. Yeah.
So maybe coming full circle, the things that triggered this for you was the discussion of it in the context of migrations, and I mean specifically like schema changes and data pipeline, like long running transactions, maybe things that take heavy locks.
It's long running transactions because if you acquire a lock, it's released in the end, so it's long running transaction.
Yeah, I was thinking on the read only ones. At least there are still massive implications, but it's not as devastating unless they're combined, right? Unless you have both.
Read-only transactions also acquire locks.
Yes, of course.
Locks. Yeah.
But they're fine until they block a
modification.
Exclusive.
So exclusive lock of coming from alter table cannot be acquired because of ongoing accessory lock from some ongoing select, which probably even finished, but there is data pipelines. They love complex long transactions, and some brief select which you executed in the beginning of transaction holds this accessory lock till the very end of transaction.
Yeah.
And it blocks alter table. It's just alter table should have low lock timeout and retries.
Yes. So that's the
That's approach, which is this is good mitigation to not to properly schedule or something, because if not the data pipeline, it can be something else. At any time, Postgres can start aggressive auto vacuum process, which will be freezing your tuples to prevent transaction ID wraparound, and this will block your DDL. If it hasn't happened yet, either it happened but you didn't notice yet, which is very common, I think.
Yeah, I think
Some,
so
I
too.
know,
Even in small,
some outage, we retried, everything good. Okay, Postgres is weird.
or
Or
even not even an outage. Maybe just some customers getting some slow,
yeah,
like things running
like
slowly for.
5 seconds or 10
Exactly.
seconds latency spike, and we don't understand why. Or you just got lucky, and it
Yeah.
awaits you next week. So
Yeah. Yeah.
everyone must understand this topic and implement low log timeout and retries until Postgres will have work concurrently in all operations,
Well,
which will make things interesting, because concurrently means you lose the transactional behavior of DDL. So it's very interesting. The future is interesting, because I think alter table should have something like concurrently or with retries, but it cannot be inside transaction block in this case. So
yeah.
it's so interesting topic, right?
Yeah, you always combine these low lock timeout and retries, and it's
Yeah.
only just struck me that if that sounds like a lot of work to people, and then retries can feel like a lot of work, actually the important part is the lock timeout. Retries, it's like,
That's a
whoa,
good point.
yeah,
Yesterday we opened gates for first clients for our Copilot product, Postgres AI Copilot, and we had a new client, which actually originally they came as consulting client, but use our product inside consulting, and like we found a lot of issues as usual. Like it's great, and observing their situation. I think it's a RDS or Aurora, I don't remember particularly, but I noticed log timeout was very low. It was very, very low. It's so interesting, 100 milliseconds. I haven't talked to them yet, I will soon, but it's like it's an interesting situation. Global log timeout is very low, right? So I even started to think, okay, log timeout, does it affect only DDL or row level logs as well? What do you think?
good question. I don't know.
Yeah, it affects all. Yeah, row level lock
Wow,
as
yeah,
well. So if you update a row but didn't say commit, so it's like multi-statement transaction. You updated a row, sit inside transaction. Another transaction just fails after 1 second. Oh, not after 1 second, after 100 milliseconds.
yeah,
And this makes me think, okay, something is not right here. You know, deadlock timeout is 1 second by default,
yeah,
but lock timeout is 100 milliseconds. So deadlock detection never happens.
yeah. In that case, yeah,
How is it possible? I'm very curious how this application feels, right? And I will be talking to them soon, I hope. And I think maybe I'm just overlooking. Maybe there are some settings at like session level, application user
maybe,
level. So this global maybe is overwritten, because it's a very interesting situation to keep it so low and global,
yeah,
right? But what you say basically, okay, forget about retries, let's just set log timeout second or 2 seconds, and maybe only for DDL, right? Not
yeah.
for
That's
other
what. All
logs.
I'm thinking is to start with, like add lock timeouts to your migrations, and then if they start failing, because they won't always, like, depending on your lock timeout and depending on your
Well,
especially
I
if you
can,
design them in a ways that is not super, if you're not doing full table
yeah,
rewrites and things.
you are right, but I can tell you what happens next. Next, pipeline runs for 10 minutes, and then it fails, and like, damn, we need to retry it whole. So retries will be longer,
Within
right?
the
Big
pipeline,
loops
I'm
of
with you now.
retries.
Yeah, yeah, yeah,
Yeah, that's why I say do retries right on. The most radical way, extreme way to do retries is inside transactions who have subtransaction. This is the only case when I can say subtransactions are reasonable. Well, I think some financial applications might need it as well, but in general case, avoid. I tend to say like avoid subtransactions. But if you have complex DDL transaction, not DDL, it can be DDL, DML, or something, and then inside it you want to have retries, and you cannot lose, you can, but it's too costly, you will need to retry a lot of stuff. You don't want to lose what you have so far in that transaction. Okay, you can use save points there, but you need to double check that save points don't go too deep in terms of nesting, 64, right? And also you need to check there are no long-running transactions, and that will affect the health, and you will see subtransfers LRU wait events. So in this case, you just retries, and if retry fails, you retry. Like if you have log timeout, if your local DDL fails, you don't lose everything. You lose only until the latest save point, then retry again. Usually it's done using PLPGSQL and begin, exception when, blah blah, end blocks.
Sure.
It will create subtransactions implicitly for you, right? And then you can retry there in this begin, exception, and block, and it's good. It's good. I mean, this is a good thing to have. And in this case, retries are super local, and whole pipeline of deployment won't fail.
Yes.
If everything is like all right. Of course, if there is long transaction running 2 hours, those retries probably won't last so much.
Yeah, it fails anyway.
So that's why I connect to these two words.
Oh, I definitely think lock timeout and retries is great. I'm just thinking there is an intermediate step if people want to get a lot of the benefit without all of the work.
Yeah. Well, I agree. At least lock timeout. Yeah, this is already it's a safeguard from downtime basically.
Yeah.
At least or partial downtime. And here, interesting that we want, like shift left testing. We want to test and find bugs earlier. Ideally, developer who developed the code finds bugs immediately, right? This is shifted to left. Here, it tries we want to shift to the right, right? Because if we shifted to like testing pipelines, CI, like it's too, it makes retry heavier, right?
Yeah, these things are also, I think, on the testing front, these are the hardest things to test as well, right? Because they're dependent on other activity in
situation,
and very few people have good test setups that have concurrent activity. It's not common.
Yeah, this is on one hand. On another hand, it's not rocket science at all, and you just need to avoid two things. I thought about this, and like in DB Lab, for example, in our tool for database branching, we eventually developed methodology where we don't need background workload because it's very uncertain. Like one day it has long-running transaction, another day we should be prepared for everything. This is our approach, and we just decided to do two things. One thing is that we need log timeout and retries. This is one thing. Just to be prepared that log cannot be acquired. Again, the log cannot be acquired sometimes because of auto vacuum, right?
Oh, in anti-wraparound mode, you mean?
Yeah, and it can run, if it's a huge tab, it can run hours sometimes. If it's throttled, it can run hours. And another thing is that we should not keep exclusive logs for long. That's it. For long means like for many seconds. They should be brief. If you if you know how to acquire logs gracefully, so not waiting for long, blocking others, and with retries, and also if you acquired log, you don't hold it too long, for long. That's it.
Yeah.
There are exceptions though. There are exceptions. For example, if you create a new table and you load data to it, well, you're technically nobody is working with this table yet, right? So if you created a table, you own the lock on it, exclusive lock. Inside the same transaction, you can load data. Why not? Right. In this case, you are breaking the rule number 2. You hold the lock too long, but it's harmless, right? So, but there are exclusions. But in general, these two rules are serving great. Like they are helpful if you keep them in mind. Graceful acquisition and don't hold it too long if it's very heavy, like lock, heaviest lock, exclusive lock. Yeah.
Sounds good. Anything else you want to touch on before we call it a day?
I think that's it. I hope it was helpful.
Yep. Nice. And I'm interested to hear if anyone gets in touch about any of this as well.
Oh yeah, I'm curious. Maybe someone from RDS will comment on this. why max connections is so high by default.
Yeah, it could be interesting.
Good.
All right. Thanks, Nikolai. Take care.
You too.
Bye.